Welcome back, everyone, to the smartest year ever, our quest to become the world's greatest conversationalist. My name is Gordy, and all this week I am sharing weird animal facts that I have researched, one bizarre creature a day, and today, the dolphin. How bizarre, but no. Specifically, how this mammal sleeps with half their brain awake and half asleep. Like and subscribe right now if you haven't, so you can keep up every single day. I do this every single day. All right, what if I told you that you could sleep and stay awake at the same time? Not like zoning out in a meeting. I mean literally, like one half of your brain is asleep while the other is alert, watching the room, monitoring the exits, and keeping you alive. That is exactly what dolphins do. It's called Unihemispheric slow wave sleep, or USWS, and I will be saying USWS because Unihemispheric slow wave sleep is a mouthful, and it's a rare time where that an initialism that has the letter W is actually shorter than the word itself. You know, that's W for you, am I right? All right, one half of the brain is fully asleep while the other half stays awake in unihemispheric slow wave sleep. I just broke my own rule. In USWS, that's how it works. So dolphins take turns closing one eye at a time. The closed eye always being opposite the sleeping hemisphere, because dolphins, like humans, have a contralateral brain organization, meaning that each hemisphere of the brain primarily controls and processes information from the opposite side of the body. So the left hemisphere, controls the right eye and the right side of the body, while the right hemisphere will control the left eye and the left side of the body. And this is pretty universally true across all vertebrates, including birds. So now, why would evolution lead to this half-brain sleep, though, for dolphins? Well, for one, because dolphins don't breathe like us, right? They can't just drift off and let the autonomic nervous system handle it. Every dolphin breath is a conscious decision. If both halves of the brain shut down at once, the dolphin would drown. So instead, one side sleeps while the other handles the essentials: swimming, surfacing, avoiding sharks, and the sleeping half literally just takes a nap while the other half pilots the dolphins around. It's been shown that they do this for about 2 hours per half at a time. In EEG recordings, electroencephalograms, have confirmed that this exists, and this is true in both wild and captive dolphins, that it's not just solely about breathing, though. Staying half awake also helps with social awareness and predator detection, as I mentioned. Just in case like a tiger shark shows up during your nap or something. And we'll talk about tiger sharks tomorrow, a little tease. But you may ask, this is the question I had. So if they have contralateral brain organization like we do, where one side and opposite side is controlled by the opposite hemisphere of your brain, does a dolphin lose control of half of their body when with the contralateral setup? So if the one side's sleeping, if the right side sleeping, is the left side of their brain or left side of their body like completely worthless? Well, not exactly. Even though only one hemisphere is asleep at a time, motor control in dolphins doesn't really go fully offline on one side the way you might expect if it were strictly contralateral like in humans. I thought this was all interesting. Their motor systems are more bilaterally integrated, and autonomic control, like swimming in slow circular patterns or surfacing for air, is preserved even during unihemispheric sleep. So while some fine control may be reduced, actually, they don't just swim in circles or flop over or something. So I was wondering, do they just go in circles then if one side of their body doesn't work? But to a degree, dolphins have been observed swimming slowly in slightly curved paths or floating near the surface in a kind of torpedo-like state. But they remain coordinated, though. They remain more coordinated than we would in that case. And I'll explain why, because I think the actual neuroscience behind it is super fascinating. So for starters, they're corpus callosum. And that's the thick cable of nerves that connects the two brain hemispheres in most mammals. In dolphins, it's a relatively reduced corpus callosum. And so this suggests that their brain hemispheres can operate more independently than ours. The corpus callosum allows for communication between the hemispheres in our brains. And so for dolphins, with a smaller corpus callosum, those hemispheres can operate more independently, as I just mentioned. So during USWS, that is exactly what happens. One hemisphere powers down into slow wave sleep. You'd see if you remember this from any science classes or studies, you'd see low frequency, high amplitude EEG patterns, and while the other stays wide awake with normal brain activity. So it's like napping with half of your brain while the other half stays on guard duty. And the split brain behavior is driven by neurotransmitter regulation, especially acetylcholine. Studies using EEGs and microdialysis in dolphins show that acetylcholine stays high in the awake hemisphere but drops in the sleeping one, and that shift lets one side stay alert while the other one rests and recovers. And dolphins aren't alone with this. This weird split brain sleep happens in other species too. Most whales, especially toothed whales like sperm whales and orcas, things like that, they sleep with one half of their brain at a time as well. Some birds, like mallards, they do the same thing. Ducks sleeping in a row will literally have the outer ducks keep one eye open with the opposite brain hemisphere staying alert. In fact, migratory birds also may fly thousands of miles while sleeping half a brain at a time. I think that's pretty cool, pretty impressive. And scientists believe this may be a case of convergent evolution, where different species independently evolve similar solutions to the same problem. So it's like, how do you sleep without fully letting your guard down? That's the problem, and there's the solution. So now let's talk about humans. We can't do unihemispheric sleep, but there actually is one fascinating, strange exception, and it is the first night effect. When people sleep in a new environment like a hotel, or you do like a sleep test in a lab, the left hemisphere of the brain stays more alert. It's not like I'm full on half and half dolphin mode. It's less pronounced than that, but it is like an evolutionary alarm system that's still running diagnostics. That's why if you've ever slept poorly that first night in a new place, it's usually just your brain like getting its dolphin on. And the other question I was wondering was do dolphins dream, right? So, and the answer is a bit tricky, because dreaming, as you may know, is usually associated with REM sleep, when both brain hemispheres are active and muscle tone shuts down. But if dolphins are only sleeping one hemisphere at a time, do they ever enter REM? And if they don't, do they ever dream? And so the answer is kind of maybe, but not like we do. Some studies suggest dolphins show brief REM-like activity, but it's rare and it's difficult to measure. So they may dream or they may not, which makes dolphins kind of the ultimate sleep minimalists. They're always aware, never fully offline, and still they somehow thrive. Their memory doesn't take a hit, anything like that. They get restorative sleep, essentially. So there you have it. Dolphins, the breath-holding, half-brained, ocean-gliding creatures who nap with one eye open and still manage to smile about it. Thanks to all my sources, which can be found in the YouTube description. Go check those out. Go check out the 1-minute version at Smartest Year Ever on your favorite social media sites. Let me know how many hemispheres of your brain you sleep with. And in the meantime, stay curious and stay clever on our quest to become the world's greatest conversationalist. I will see you tomorrow in the Smartest Year Ever. More Animal Week.